About 66 million years ago, Earth was a vastly different world, a realm where reptiles reigned supreme. For nearly 180 million years, an extraordinary group of creatures, known as dinosaurs, had established an unrivaled empire across every corner of the planet, from plains to jungles and mountains to deserts. They were nature's ultimate creation, unparalleled in their diversity of size, sheer power, and adaptability. Some were as colossal as mountains, while others were as small as birds. Some were ferocious predators, while others were gentle herbivores. It seemed as though their reign would last forever. Yet any earthly empire pales in comparison to the vastness of the cosmos. At a time when life on Earth was thriving, a silent killer was hurtling from the infinite void of space. An asteroid, larger than Mount Everest and spanning roughly 10 to 15 kilometers in width, was racing toward Earth at speeds exceeding 20 kilometers per second. Upon entering the atmosphere, it transformed into a blazing fireball, shining 1,000 times brighter than the sun. That afternoon, the last dinosaur roaming the Earth might have looked up and witnessed what appeared to be a new sunrise. But it was no sunrise. It was a cosmic death sentence. Within moments, the asteroid slammed into the Earth near the Yucatán Peninsula in present-day Mexico. The entire planet shuddered from an explosion more powerful than the combined force of billions of nuclear bombs. In an instant, millions of years of evolution, nature's greatest masterpiece, fell victim to a cosmic catastrophe and began its descent into extinction. How did these incredible creatures emerge? What stroke of fortune or evolutionary opportunity allowed them to become the undisputed rulers of the Earth? And what exactly transpired on that fateful day and in its aftermath to reduce their invincible empire to dust? From the very first pulse of life to the rise of the dinosaurs and their tragic demise, we will explore that epic journey in today's episode of Past and Present USA. According to scientists, the journey of life began approximately 4 billion years ago in the depths of the ocean. For billions of years, life remained microscopic. However, about 540 million years ago, during the Cambrian period, an incredible explosion of life occurred, filling the oceans with diverse creatures. Gradually, plants and subsequently animals emerged onto land. Amphibians were the first vertebrates to inhabit the land, yet they remained dependent on water for reproduction. Evolution provided a groundbreaking solution to this dependency: the amniotic egg. The hard shell of this egg protected the embryo from the dry environment, enabling reptiles to spread into the Earth's arid interior regions and adopt a truly terrestrial lifestyle. Among these reptiles, the synapsids, or mammal-like reptiles, rose to dominance during the Permian period, roughly 300 to 250 million years ago. They were not the ancestors of dinosaurs, but rather distant forebears of modern mammals. The Earth was then under their dominion. However, approximately 252 million years ago, the most catastrophic event in the history of life occurred: the Permian-Triassic extinction, or the Great Dying. Massive volcanic eruptions lasting millions of years in present-day Siberia, known as the Siberian Traps, released billions of tons of greenhouse gases into the atmosphere. This caused global temperatures to skyrocket, depleted oxygen levels in the oceans, and unleashed devastating acid rain that destroyed the plant world. This cataclysm wiped out about 96% of marine species and 70% of terrestrial vertebrate species. The mass extinction turned Earth into a nearly lifeless planet and effectively obliterated the dominant synapsids, which had ruled the world for millions of years. Yet, by the laws of nature, new opportunities often emerge from the ruins of cataclysmic disasters. This extinction event so thoroughly disrupted Earth's ecosystem that it opened a new door for evolution. A new group of contenders emerged to fill the void that had been created: the archosaurs, or ruling reptiles. And it was from among these archosaurs that the most influential creatures in Earth's history, the dinosaurs would arise. The mass extinction was the pivotal event that set the stage for the rise of the dinosaurs. After the mass extinction, Earth was a ghostly realm, a shadow world. The planet, once vibrant with the clamor of life, had fallen silent. This new era, the Triassic, began amidst extreme adversity. The supercontinent Pangaea remained intact, its vast interior dominated by scorching, arid deserts. Life had to wage a renewed struggle for survival in this harsh environment. It was within this struggle that the archosaurs, or ruling reptiles, rose to prominence. The evolutionary tree of archosaurs split into two main branches, distinguished by the structure of their ankle bones. One branch comprised the Pseudosuchia, or crocodile-line archosaurs. The other was the Ornithodira, or bird-line archosaurs, the lineage that would eventually give rise to pterosaurs and dinosaurs. During the Triassic, the Ornithodira were the underdogs. The ecosystems of the time were dominated by the Pseudosuchians, fearsome predators like the 20-foot-long Postosuchus, armored herbivores like the Etosaurs, and crocodile-like aquatic hunters, known as Phytosaurs, were the key players of the era. It was in their shadow, approximately 230 million years ago, in what is now Argentina, that the first true dinosaurs emerged. So, how did dinosaurs rise from such obscure beginnings to become the rulers of the Earth? The answer lies in certain revolutionary adaptations within their bodies, adaptations that provided them with a unique biological toolkit. The first and most crucial of these was the structure of their hips and legs. Dinosaur hip bones featured a hole, or perforated acetabulum, that allowed the femur, thigh bone, to be positioned vertically, directly beneath the body. This upright posture, or erect stance, was a groundbreaking evolutionary innovation. This gave them the ability to move much faster, more efficiently, and with less energy expenditure compared to competitors like the Pseudosuchians. They were nature's marathon runners. Secondly, their respiratory system was likely incredibly efficient. Based on fossil evidence and their close evolutionary relationship with birds, scientists believe dinosaurs possessed air sacs connected to their lungs. This system ensured a unidirectional flow of air through the lungs, allowing for greater oxygen intake with every breath, a massive survival advantage in the relatively low oxygen environment of the Triassic period. Thirdly, there is the matter of their metabolism. Although there is debate, were they cold-blooded like modern reptiles or warm-blooded like birds and mammals? Most scientists now believe they were likely somewhere in between, or mesothermic. Their rapid bone growth rates and predator-prey ratios suggest they led much more active lives than modern reptiles. Armed with these physiological advantages, the first dinosaurs, such as the 1-meter-long Eoraptor and the somewhat larger Herrerasaurus, began their struggle for survival in the harsh world of the Triassic. They were fast, agile, and opportunistic, giving them a distinct strategic edge over their larger, slower competitors. But fate once again favored the dinosaurs. Approximately 201 million years ago, at the end of the Triassic period, another mass extinction event occurred, known as the Triassic-Jurassic extinction. The likely cause was massive volcanic activity in a region known as the Central Atlantic Magmatic Province. The vast quantities of carbon dioxide released during these eruptions drastically altered the climate and acidified the oceans. This catastrophe mysteriously wiped out the dinosaurs' main competitors, such as the Pseudosuchians, yet, remarkably, the dinosaurs survived. Scientists believe that their small size, efficient respiratory systems, and high metabolic rates likely helped them rapidly adapt to this changing environment. Regardless of the cause, the outcome was clear. The second extinction event was a magnificent gift from nature to the dinosaurs. All obstacles in their path had been removed, and the world lay open before them. To fill the ecological void that had emerged, dinosaurs began to evolve with incredible diversity during the subsequent era, the Jurassic, establishing themselves as the undisputed rulers of the Earth. Thus began the Golden Age of dinosaurs. Over the next 140 million years, spanning the Jurassic and Cretaceous periods, dinosaurs established an empire unlike any other group of animals in Earth's history. It was an epic saga of immense size, displays of power, and the ultimate triumph of evolution. During the Jurassic period, the supercontinent, Pangaea, began to break apart, creating new oceans between the continents. This caused Earth's climate to shift dramatically. The arid deserts gave way to a warm, humid, and lush green landscape. Vast forests of cycads, conifers, and ginkgos flourished. In this abundant paradise, the largest land animals in Earth's history, the sauropods, emerged. These herbivorous giants were living marvels of engineering. Their sheer size served as their primary defense against predators. Brachiosaurus stood as tall as a 4-story building. Its giraffe-like physique enabled it to browse leaves from the tops of tall trees. Creatures like Diplodocus and Apatosaurus were incredibly long. Their elongated necks were balanced by even longer whip-like tails, appendages likely used to fend off predators. To sustain such massive bodies, they possessed remarkable physiological adaptations. Much like birds, their vertebrae contained air sacs, keeping their colossal skeletons relatively lightweight yet strong. These air sacs also facilitated a unidirectional flow of air through their lungs, ensuring a steady supply of oxygen to their massive bodies, which required immense energy even for simple actions like walking. Furthermore, they functioned as living food processing machines. Instead of chewing, they would tear off leaves and swallow them whole, using gastroliths, or stomach stones, to grind the vegetation within their vast intestines, where microbes would then break it down for digestion. It was impossible for such massive creatures to incubate their eggs for extended periods. Fossil sites like Aucamahuevo in Argentina reveal that they excavated nests in large colonies, laid their eggs, and covered them with soil, much like modern sea turtles. During the Jurassic period, fearsome predators like Allosaurus hunted these colossal herbivores. Measuring approximately 30 feet in length, the Allosaurus was equipped with sharp teeth and powerful claws featuring 3 digits. Evidence from the famous Morrison Formation fossil site in North America indicates that Allosaurus was the era's most common large predator and often hunted massive creatures like sauropods in packs. Other predators included Ceratosaurus, distinguished by a horn on its snout, and even larger ones like Torvosaurus. The diversity and population of dinosaurs reached their peak during the Cretaceous period. It was during this time that a revolutionary change occurred on Earth: the emergence of flowering plants, or angiosperms. The advent of flowers added color to the landscape and created new, nutritious food sources, such as fruits and seeds. This Cretaceous terrestrial revolution influenced the evolution of new insects, like bees, ants, and butterflies, and creatures such as birds, while also triggering an explosion of new dinosaur species. It was during this era that we see some of the most familiar and fascinating dinosaurs, such as Tyrannosaurus rex, or T-Rex. It was the unrivaled apex predator of its ecosystem. Its skull was massive and powerful. The broadness of the rear section allowed for binocular vision, which was highly effective for gauging the distance to prey. It possessed around 60 sharp, banana-shaped teeth, capable of delivering a bite force of approximately 8,000 pounds, enough to crush the bones of any animal. Its incredible sense of smell enabled it to locate prey or carcasses from a distance. While its 2 small arms have been the subject of much debate, they were likely used to grasp prey at close range or to maintain balance when rising from the ground. Fossil evidence of feathers found on ancestors like China's Yutyrannus suggests that the T-Rex too might have possessed feathers at some stage of its life. Hadrosaurs, or duck-billed dinosaurs, were the cattle of the Cretaceous period. For millions of years, they roamed in vast herds. Their duck-like bills housed hundreds of rows of teeth known as dental batteries. These teeth were constantly replaced, enabling the animals to effectively chew even tough vegetation like cycads. Parasaurolophus possessed a long, hollow crest atop its head. Scientists believe that by forcing air through this crest, the dinosaur could produce sounds at specific frequencies to communicate with others of its kind. Triceratops was the most famous member of the ceratopsian, or horned dinosaur group. Its massive bony head frill and 3 sharp horns served as impenetrable armor against the terrifying bite of the T-Rex. However, these horns and frills served purposes beyond mere self-defense. Species like Styracosaurus featured numerous smaller horns around their frills. These varied horn and frill structures were likely used for species recognition and attracting mates, much like the antlers of modern-day deer. While raptors or dromaeosaurids gained popularity through movies, the real-life creatures were even more fascinating. Velociraptor was roughly the size of a turkey, whereas Deinonychus was closer to human size. Fossil evidence reveals that they were highly intelligent, feathered, and warm-blooded. They possessed a sickle-shaped claw on the second toe of each foot. The famous fighting dinosaurs fossil discovered in Mongolia captures a moment where a velociraptor was buried in sand while attacking a protoceratops, with its deadly claw embedded in the prey's throat. This serves as proof that they were formidable predators. By the end of the Cretaceous period, Earth hosted a rich and complex ecosystem. Dinosaurs were at the peak of their evolutionary success. The fossil record from North America's Hell Creek Formation offers a glimpse into those final moments, revealing a world where Tyrannosaurus, Triceratops, and Edmontosaurus coexisted. It seemed as though nothing could shake the foundations of their reign. But they did not know that a cosmic messenger was hurtling from space to bring the final curtain down on their glorious 180 million year reign. It was a day much like any other. About 66 million years ago, on a spring day in the northern hemisphere, life was proceeding normally in the shallow tropical waters off Mexico's Yucatán Peninsula. Small creatures roamed the mangrove forests, while fish and ammonites swam in the sea. Little did they know that a moment destined to seal their fate and that of the entire planet was mere seconds away. At that instant, a silent killer, the Chicxulub asteroid, hurtled in from the infinite void of space. Larger than Mount Everest and spanning roughly 10 to 15 kilometers in width, this massive rock entered the atmosphere at a speed of approximately 72,000 kilometers per hour, 20 times faster than a bullet. Friction with the atmosphere transformed it into a terrifying fireball, blazing with a brilliance 1,000 times greater than the sun. Creatures on Earth looked up to see a second sun rapidly descending toward them. Within seconds, it slammed into the waters off the Yucatan at an angle of approximately 60 degrees. This oblique impact was particularly devastating, as it propelled a vast amount of debris in a specific direction, primarily toward North America. The force of the explosion was equivalent to that of 10 billion Hiroshima bombs. This single impact net gouged a massive hole, an impact crater, into the Earth's crust, measuring roughly 180 kilometers across and 20 kilometers deep. The force of the explosion caused the asteroid, along with thousands of cubic kilometers of rock water, dust, and debris from the Earth's surface, to instantly vaporize, melt, or shatter. This event ranks among the most powerful explosions to occur in our solar system since its inception. The immediate impact of the collision was unimaginable. Within a radius of several thousand kilometers from the blast site, everything, dinosaurs, vegetation, and rock, was instantly vaporized. A terrifying shockwave surged outward at speeds exceeding that of sound, flattening everything in its path. Immediately following this came intense thermal radiation, spreading at the speed of light and igniting forests thousands of kilometers away, while simultaneously burning unprotected animals alive. The impact with the ocean triggered a terrifying mega tsunami. The initial wave was likely over a mile high. These cataclysmic waves surged outward at speeds of hundreds of kilometers per hour, completely devastating the coastline of the Gulf of Mexico. The impact of the tsunami was so powerful that it reached the interior regions of North America. Evidence of this has been found in places as far away as northern Yakutia. The explosion likely generated an earthquake measuring 11 or higher on the Richter scale, causing the entire planet to shake for hours. These tremors triggered volcanic eruptions and landslides across the globe, wreaking further havoc and destruction upon the Earth. The explosion hurled trillions of tons of rock, dust, and vaporized asteroid fragments high into the atmosphere and even into space. These heated particles, known as ejecta, began to fall back toward Earth after a few hours, pulled by gravity. As they re-entered the atmosphere, they transformed into tiny glass-like particles, or tektites, streaking through the sky like meteors. A rain of these burning particles swept across the entire sky, turning the atmosphere into a blazing furnace. This rain of fire raised the temperature of the upper atmosphere by hundreds of degrees. This unbearable heat ignited catastrophic wildfires across the globe. The dinosaurs that had survived the initial blast and the tsunami could not escape this worldwide firestorm. Their feathers or skin were scorched, and the very air they breathed turned searing hot. Within just a few hours, the dinosaurs' green paradise, nurtured over 180 million years, was transformed into a burning hell. The planet Earth was ablaze. But the most terrifying chapter had not yet begun. The initial devastation was merely the start. The true killer was invisible, cold, and enduring. After the initial barrage of fire subsided, an eerie cold silence descended. The sky turned dark. Trillions of tons of dust hurled into the upper atmosphere by the explosion, ash from global wildfires, and, most significantly, sulfur aerosols formed from the vaporization of sulfate-rich gypsum rock in the Yucatan created an impenetrable cloud layer that blanketed the entire globe. Irrefutable evidence of this event is clearly preserved in the Earth's geological strata. A thin black line, known as the KPG, Cretaceous-Paleogene boundary, is visible within rock layers worldwide at the transition between the Cretaceous and Paleogene periods. An unusually high concentration of iridium, a rare metal, was found in this layer, which was first discovered at Gubbio, Italy. While iridium is scarce on Earth, it is abundant in asteroids. Additionally, shocked quartz is found in this layer. It contains a type of crystal formed only under extreme pressure, such as that from a nuclear explosion or an asteroid impact, and tektites, or small glass spheres created when molten rock cools. This layer serves as the global signature of the Chicxulub impact. This cloud of dust and sulfur formed an impenetrable barrier against sunlight, plunging the Earth into a deep, endless night. This phenomenon is known as impact winter or nuclear winter. According to computer models, even during the day, the sky was darker than a moonless night. Nearly 99% of sunlight was blocked out. As a result, the Earth's average temperature dropped dramatically by approximately 26 degrees Celsius or 50 degrees Fahrenheit. Temperatures in tropical regions also plummeted below freezing. The Earth transformed into a frozen, dark planet. This darkness and cold likely persisted for months, or even years. This endless night and freezing cold were the primary causes of a mass extinction. The consequences were far-reaching and devastating. For instance, without sunlight, plants could not perform photosynthesis. It was akin to dropping an atomic bomb at the very base of the food chain. Almost all land and marine plants, as well as phytoplankton, perished. The fossil record reveals a fern spike following this period. Essentially, ferns were the first plants to regenerate after the catastrophe, as their spores can remain dormant for extended periods. With the loss of vegetation, massive herbivorous dinosaurs such as Triceratops, Edmontosaurus, and Ankylosaurus began to starve to death due to a lack of food. Their enormous bodies required hundreds of pounds of food daily, a supply that was no longer available on Earth. As herbivores went extinct, apex predators like Tyrannosaurus, T-Rex, and Dromaeosaurs also perished due to a lack of food. Their prey had vanished. They likely survived for a time by feeding on the carcasses of other dead dinosaurs, but eventually, they too succumbed to starvation. The same scenario unfolded in the oceans. Phytoplankton formed the foundation of the marine food chain. Their demise led to the death of the zooplankton and small fish that depended on them. Consequently, marine creatures with coiled shells, such as ammonites, as well as massive marine reptiles like plesiosaurs and mosasaurs, also went extinct. Furthermore, the sulfur released by the explosion mixed with atmospheric water to produce devastating acid rain. This acid rain persisted for years, rendering surface ocean waters as acidic as vinegar and proving fatal for organisms with calcium carbonate shells. In the wake of this global catastrophe, approximately 75% of Earth's species, including non-avian dinosaurs as well as pterosaurs, ammonites, and mosasaurs, went extinct. This means that about 25% of species managed to survive that catastrophic event. The question now arises, who survived and why? Surviving on Earth after this cataclysm was a formidable challenge. The very meaning of survival of the fittest had changed. Massive size and strength were no longer the criteria for survival. Instead, they were a liability. Those who survived shared certain common characteristics, such as small size. No land-dwelling animal weighing more than 25 kilograms, 55 pounds, managed to survive. Smaller animals required less food and could easily hide. Furthermore, it was the generalists, creatures capable of consuming a wide variety of items such as insects, earthworms, decaying organic matter, and fern roots, that ultimately survived, while those with specialized diets went extinct. Meanwhile, animals that could take refuge in underground burrows, caves, or freshwater environments managed to protect themselves from the initial thermal radiation and the subsequent harsh environmental conditions. Freshwater ecosystems suffered less damage than terrestrial ones because their food chains relied more heavily on decaying organic matter. Certain reptiles, such as crocodiles and turtles, managed to survive. This was because they were cold-blooded. Their metabolic rate was slow, and they could go without food for long periods. And most importantly, small rat-like mammals, the ancestors of Homo sapiens, survived by hiding beneath the debris. That long night, which had dragged on for years, finally came to an end. Dust particles gradually cleared from the atmosphere, and sunlight began to reach the Earth once more. Yet, it was a new world. The once clamorous realm of the dinosaurs had fallen into silent emptiness. After 180 million years of undisputed dominance, they were now reduced to mere fossilized memories. For the survivors of that cataclysm, a new opportunity lay ahead in this empty world. New life forms emerged to fill the vast ecological void left by the dinosaurs' disappearance, and it was the mammals that seized this opportunity. During the age of dinosaurs, mammals were small, nocturnal creatures that lived in the dinosaur's shadow. However, after the dinosaurs went extinct, they no longer needed to hide, nor did they face competition for food and habitat. In this newly open world, mammals underwent an incredible adaptive radiation. They began to increase in size, adapted to new dietary habits, and gradually occupied the niches once held by dinosaurs. Within just tens of millions of years, the Earth teemed with a diverse array of mammals, such as horses, bats, and primates. But has the story of the dinosaurs truly come to an end? The answer is, not entirely. One branch of the dinosaur family survived that cataclysmic event. During the Cretaceous period, a group of theropods, carnivorous bipedal dinosaurs, gave rise to feathered, flying creatures. These are the birds. Yes, the birds we see around us today, from sparrows to eagles, are all direct descendants of dinosaurs. So, whenever you see a bird, remember that you are looking at a living dinosaur. From the first stirrings of life to the epic rise of the dinosaurs and their sudden demise, this story reminds us of both the abundance and the uncertainty of life on Earth. The extinction of the dinosaurs was a cosmic accident, a calamitous event that was beyond their control or imagination. Their successful reign, spanning 180 million years, proves that they were by no means failed creatures. Rather, they represented a pinnacle of evolutionary success. According to scientists, their downfall, while a profound tragedy for them, was a stroke of immense good fortune for us, the human race. Had that asteroid not struck Earth, dinosaurs might still be ruling the planet today, with mammals remaining hidden in their shadows. Consequently, intelligent primates like Homo sapiens might never have emerged. According to scientists, we have emerged from the shadow of the dinosaurs' extinction. In the vast context of the universe, nothing is permanent, and life follows an incredibly complex and unpredictable path, one where a sudden event can alter the course of history forever. Dinosaur fossils are not merely the skeletons of strange creatures from the past. They stand as silent witnesses to the depths of time and the contingency of our own existence on Earth.